Hello, thank you for watching this video. So in this video I'll be doing question 4, Physical Sciences paper 1 from November 2020 question paper. So question 1 read as follows. Ball P of mass 0.16 kg moving east at a speed of 10 meters per second collide head-on with another ball Q of mass 0.2 kg moving west at a speed of 15 meters per second. After collision, ball P moves west at a speed of 5 meters per second as shown on the diagram below. Ignore the effects of friction and the rotational effects of the balls. So, here we are. So the only thing that is missing here, I'll say 2 in fact, is the ground and the compass. This is north. So if you know north, you know east, west, south, and all of that stuff. So what they're saying, the ball P is moving east at 10 meters per second. As it is moving to that direction, it collides with a ball Q of which has the magnitude, which has the velocity of 15 meters per second, moving west. So after collision, so this is before they collide, P is moving east, and Q is moving west. So these two balls collide. After collision, the ball P moves west at 5 meters per second. They didn't say anything about ball Q. But what they said is that ignore the effects of friction and the rotational effects of the ball. So which means you assume that this is frictionless. There's no friction between the ball and the surface, and also there's no friction which will be slowing down the rotational motion of the balls. So we assume that all the energy on these balls is not lost, or all the velocity before they meet, they are not slowed down, so they are moving at constant speed freely, uniformly. That's what they are saying. So let's go to 4.1. 4.1, define the term momentum in words. What is momentum? So momentum, I'll say it is another way of quantifying the motion of an object, because we can quantify the motion of an object using the velocity. We already do that, because this is one way of quantifying the motion of that object. But momentum is another way you can quantify the motion, and it is defined as the it is defined as the product of a mass of an object and its velocity. So if you want to calculate or want to know the momentum of an object, you simply take the product of the mass of the object and its velocity. So I'm going to write it down. Momentum, so this is 4.1. Momentum. Momentum is the product of the mass of an object and its velocity. So to find the momentum of an object, you simply take the mass of an object, multiply it by the velocity of that object. That's how you find the momentum. So the symbol for momentum is P. So P is the symbol for momentum. So we can write it mathematically and say, okay, momentum is equal to mass times velocity. or for short, m times v, or others can just say mv. So, when you talk about the momentum is a vector, which means it has the direction and the magnitude. So, the momentum is a vector. It has the direction and the magnitude. So in this case, if you want to find the momentum of ball Q, of this ball P here, it's going to be the mass of this ball, which is 0.16 times 10 meters per second, which is the velocity or the speed of this object. And this object is going to the left, is moving east, which means now our momentum will be 0.16 times 10, which is 1.6. And this direction will be the direction in which the ball is going, which is the same velocity, is the same direction as the velocity. So if you know the velocity, the direction of your velocity, then you know the direction of the momentum. Because what the two quantities that we multiply here is the scalar, which is this one only have the magnitude, which is the size, and the velocity have the magnitude, which is the size and direction. So the overall answer that we're going to get here, which is the momentum, will have the direction of the velocity because it is the determining quantity in this case. So the units for the momentum, units are kg, which is from the mass, meters per second. So these are the units of the momentum. So to recap, the momentum is the product of the mass of an object and its velocity. It is a vector, which means it has the size, which is what you will get by multiplying the size of your velocity and your mass, and the direction as well. So it also has the direction, and the direction is the same as the direction of your object. It's the same. The direction of your momentum is the same as that of your velocity. So if your object is moving to the left, or if its velocity is 2 meters per second to the left, which means that object will have its direction to the left as well, or in this case, to the east. So that's how you define momentum. So we're done with this question. Then we're going to move to the next question. Okay, so we proceed to question 4.2. Question 4.2 reads as follows. Calculate the velocity of ball Q after the collision. So they want us to find the velocity of this ball Q after the collision. They have given us that ball P after the collision moves at 5 meters per second west. So they want us to investigate what is happening there. So we want the velocity of it, which is one the magnitude and direction, because that's what a velocity has. So let's go. So to do this, we use the conservation of momentum. So let me go to the next page. So this is question 4.2.1. So to calculate, to make these such calculations, you use the law of conservation of momentum. So this is the law that we use to determine what the velocity of the ball, what ball is it? Ball Q. So what does this law say? So what this law is saying that is telling us that if we have an isolated system, the total momentum is conserved. What does that mean? It means that if you sum the momentum of ball P and ball Q before they collide, it should be the same as the sum of their momentums after they collided, provided that the system is isolated. So by isolated, it means that there are no external forces that are acting on the balls. In this case, they did guarantee us and say, ignore the effects of friction and rotational effects of the ball. Which means that line is saying that we don't have external forces that are acting on these balls. So the system that we have is isolated. So we have an isolated system where there are no external forces that are disturbing the motion of these balls. So let's write this down. So what this law says is that in an isolated system, very important, isolated. By isolated, we say we don't have external forces. There are no external forces on this system of ours. Which is now, they said that they ignore that rotational friction and friction with the surface. So we are guaranteed that this system is isolated. In an isolated system, there total linear momentum is conserved. So what does this mean? This means that if you take the sum, you said that momentum is represented by P, by symbol P. So what this means is, if you take the sum of momentum, so this is the momentum of Q, and add it with the momentum of P before the balls collide, it should be the same as the momentum. Should be the same as momentum of Q plus the momentum of P after collision. This is what this thing says. The law of conservation of momentum tells you that if you have an isolated system, the sum of the momentums of your objects before they collide, it should be the same as the sum of the momentum after they do collide. That's what this law of conservation of momentum is saying. So in this case, we are assuming that it's one-dimensional, so these are just moving in a line. So that's what our previous drawing is showing us. So we use this principle to find out the momentum of the other object. So let's go back. So ball Q, ball M, so this is the momentum of Q before collision, momentum of ball P before collision, momentum of ball Q after collision, and the momentum of ball P after collision. So to find this momentum, we know that momentum is the product of mass and velocity, which is equal to mv. To find this, we know that it's going to be the mass of P. It's going to be the mass of Q times V initial of Q. So this is the momentum of ball Q. It's going to be the mass of Q times the initial velocity of Q, plus the mass of P times initial velocity of P, which is ball P. This should be equal to what? The mass of Q times final velocity of Q plus I'm going to write it down here because I don't have enough space. Mass of P times final velocity of P. This is what this looks like. So these are the ones, this is the sum of momentum before collision. That is the sum of momentum after collision. So, to continue with this, the only thing that is left for us to do is to substitute. So, we're told that the mass of this ball P, the mass of ball P, of ball Q is 0, okay. So, one thing that you must also take into account, you must decide your directions. You must choose directions. For example, you were told that so this is north, this is east. So you were told that the other ball is moving north, the other is moving east. You were told that the other ball is moving east and the other is moving west. So when you're working with vectors, you always have to choose direction and stick to it. For example, if you're saying ball Q, let me go back to the first slide. If you're saying this ball, this direction of this ball is negative. So if you're taking this, saying this ball P that is moving to the east has a negative direction. So you have to choose whether your ball has a negative or positive direction. That is what you have to do. So for example, if you're saying P has a negative direction, all the answers of velocity that have a negative sign will mean that it was on that direction of P, which was east. So if you're saying this one is negative, then this one will have a positive sign, and vice versa. That's what you should do. Choose the direction and stick to that direction when you're doing calculations. So that's what we're going to do. We must. Oh boy. Okay. So we must stick to that direction. Okay. So now, in this case, I'm choosing P to east to be positive. So I'm taking this direction to be positive. I'm taking that one to be negative. So everything that is moving to the right, or in this case to your left, which is to the east, it has to your right, it has a positive sign. Everything that is moving west, according to this, it has a negative sign. So that's what I'm going to do. So let's go there. Okay, so we're going to substitute here these values on this equation of ours. But I'm going to restart on the next page because I ran out of space. So I said it's M Q VIQ plus MP VIP is equal to, which is, this is the initial momentum of Q, this is the initial momentum of P, is equal to MQ VF Q plus MP plus VF P. This is it. So in this case, I said that I will take this ball Q, which was going west, as negative, and then ball P, which was going east, as positive. So this one that was going west, I'm taking as negative. Ball P, which was going east, is positive. So the mass of ball M is 0,2 times the velocity of ball Q. It was 15 meters per second west, which is this direction. So this direction to me is negative. So it's going to be negative 15 plus the mass of ball P, It was 0,16. 0,16 times the velocity of ball P. What was it? The velocity of ball P, it was 10 meters per second, going to that direction east, which is positive to me, 10. So what I'm saying is, when I add this momentum before, it should be the equal the momentums after. That's what I'm saying. This is what the conservation of momentum, law of conservation of momentum says. So ball Q, mass of ball Q, it was 0,2 times final velocity of Q. The final velocity of Q is what we want after the collision, because you were given the initial velocity of Q before collision, and they did tell you that the initial velocity of ball Q before collision was 15 meters per second west, which is this one. But the final one after the collision you are not given. That's what you want. So you leave it out as an unknown. So you write V final of ball Q. That's what you write. Because that's what you don't know. That's what you want to investigate. Then plus the mass of P, which is 0,16, 0,16 times this is times here, times the velocity of ball P after the collision. You were told that this ball, the velocity of this ball P after the collision was 5 meters per second west. So which is, it was moving in this direction. So I chose this direction to be negative. So it should be what? It should be negative 5 here. Once you have this, you can use your calculator to find out what this means. So punch this on your calculator, 0,2 times negative 15 plus 0,16 times 10. The answer is this, is negative 1.4. Answer is negative 1.4 is equal to. So in this times this times this 0,2 VF Q, which is just the product of that. Then you take the product of these two. So what is it? It's 0,16 times negative 5. Your answer is negative 0,8. What do? We transpose this negative 0,8 to this side. It was negative, it will be positive to this side. So what do we have? We have negative 1.4 plus 0,8, which is equal to 0,2 VF Q. So you divide by 0,2 both sides of the equation, 0,2 both sides of the equation. This one cancel out, we're left with 1 there. So we have VFQ. You have VFQ equal to the sum of that, which is negative 1. The simplification of this, which is what is it? It's negative 1.4 plus 0,8 divided by 0,2. And the answer is negative 3 meters per second. So this is the velocity. What does this mean? It means that since you are given a ball P to be moving in this direction, you are told that it was moving at 5 meters per second. Now ball Q was just left here with no direction. This was ball Q. But now you have just calculated that the velocity of this ball after the collision of ball Q is 3 meters per second. And since it has a negative sign, according to our coordinate system, it should be moving to the left. Which means now the ball Q is also moving in this direction at 3 meters per second. So you can say here, therefore, Q has a velocity of what? Of 3 meters per second. west. That's what the velocity of ball Q is. And we are done with this question. We're done with it. What next? We go to the next question. How does the next question read? 4.2.1. Calculate the magnitude of the impulse on ball P during collision. They want us to calculate the magnitude of the impulse. So it's 4.2.2 impulse. So they are saying calculate the magnitude of the impulse on the ball during collision. What is impulse? So impulse. Impulse is the change. Is the change in momentum. It's the change in momentum of the ball. So the impulse is the change in momentum. What causes the change in momentum? The change in momentum. Let's say now, okay, in this case, they're saying calculate the magnitude of the impulse on ball P during the collision. So the impulse is the change in momentum of ball Q, of ball P, in this case, because they want us to calculate the impulse on ball P. So the impulse is the change in momentum of the ball P due to the force that is acting on it, which is now, this impulse, which is this change in momentum, is caused by the force that is acting on ball Q. So the force that is acting on ball P is the one that causes the change in momentum of the ball. So now, you had this ball here, ball P, then colliding with ball Q here. So this ball here had the momentum going to this direction, and this one had the momentum going to that direction. So this was P, the direction of ball P was of the momentum of this ball P was in this direction. The momentum of ball Q was in this direction. So now, after the collision, the momentum of P did change. What caused the change was the force of this ball acting on this. Was the force of ball Q acting on ball P, which caused P to eventually turn away. That's what caused the change in momentum. So the impulse, it is the change in momentum of the ball, but it is caused by the force that is acting on the ball. So the force that was acting on the ball was the force of Q on this ball P. So momentum is the change in momentum, impulse is the change in momentum of the ball P caused by the force of ball Q on P. So the impulse, which is the impulse in this case, okay, not in this case, the impulse, it is the change in momentum of the ball. But what causes the momentum of the ball to change? It is the force of another ball Q on P. So now what they want us to find, they want us to find the impulse, which is the change in momentum. So the impulse is going to be, what is it? Impulse. Is equal to the change in momentum, which is P. So this impulse, impulse is denoted by J, which is equal to change in momentum, which means momentum final minus momentum initial, which is equal to what? M V F minus M V I, which is equal to M, common factor, Vf minus Vi. This is our impulse. This is equal to, the mass of P was 0.16 times final velocity, which was -5, minus initial velocity, that was 10. So the momentum is equal to this. The impulse, 0.16 into -5 minus 10. So the impulse is -2.4 kg meters per second, which on other terms you can say, okay, the impulse is equal to 2.4 kg meters per second. Which direction? Negative, west. That's the direction of a negative side. In our case, it's west. So, as I said, the impulse is caused by the force of another object acting on our object of interest. So in this case, it is this change in momentum is caused by the force of Q acting on P over for a given amount of time or some interval of time. So what I'm trying to say is, in other terms, so I'm saying that the force of Q over a given period of time, some interval, caused what? The change in momentum. So the force of Q acting on T caused the change in momentum. Or the force of Q acting on P caused the change in momentum. So that force of Q exerted on ball P caused the change in momentum. So that's it.